Okay, here's my solution for the problem that we did Tuesday of week 1. This was a great problem. This was the problem about the astronaut. Here's the astronaut on the surface of an unknown planet. And she has a softball. And we used the fact, the observation really, that we'll come back to in this class, that the acceleration due to gravity alone is uniform and constant. You might hear me use these words more in this class. I use the word uniform to mean the same everywhere, meaning at all points in the ball's trajectory, and constant means the same over time. So if the ball flies upward and then 2 seconds pass, the acceleration due to gravity is still the same. And we talked in class about how you might measure this. Okay, so, but our astronaut knows that it's going to be constant and uniform. She just doesn't know what the value is. And so what she does is she takes a ball and she throws it upward at 20 meters per second and notes that it goes to a height of 40 meters. Maybe she's got her rocket ship lined up, or she has measured off distance on a cliff face, and somehow she measures that. Okay, so the question is, what is the acceleration due to gravity? And this again is one of those kinematic equations. So we should start by writing down the kinematic equations for constant acceleration. We have that x is x naught plus v naught t plus 1/2 a t squared, and velocity is the original velocity plus the acceleration times time. And the issue here in this problem is that we don't know time. And both of these equations have time in it. So that's kind of a sticky problem. But remember, when we have two equations and they're both true, this is a system of equations. And so what we can do is we can take one of the equations and solve it for time. So I'm going to take the velocity is v naught plus at, and I'm going to solve for time. And I get that time is v minus v naught over a. And then I'm going to substitute that into the second equation. And so I get that x equals x naught plus v naught. And every time I see t, I'm putting in v minus v naught over a plus 1/2 a, I have to write over myself here, v minus v naught all over a squared. The square is important here. And now I do some algebra. X is x naught, so v naught v minus v naught squared over a plus 1/2 a v squared minus 2v v naught plus v naught squared all over a squared. And one of the a's cancels. So let's see, what am I left with now? So I'm going to put everything under a, I guess. So x is x naught plus everything under a is v naught v minus v naught squared plus, let's see, 1/2 v squared minus v naught plus 1/2 v naught squared. And I see that I can do some combining. In fact, these two terms cross out right away. That's convenient. And then I can combine this term and this term. And so I get that, let's see, so this is x naught. And let's see. So when I combine those two terms, I'm going to get a positive 1/2. And so, wow, everything's going to have a 1/2. So I'm going to have 1/2. Let's see, 1/2 v squared minus v naught squared all over a. And so if she wants to find a, what she's going to do is solve for A. So I get that A, and I'm going to just sort of do this algebra here myself. Let's see if I can do it in my head. So I'll bring the x naught over here, and then I will multiply by 2. Okay, so I get v squared minus v naught squared all over 2x minus x naught. So in fact, as we mentioned in class, this is an aha moment, because this is what some people call the third kinematic equation. But really, it's just sort of some algebra, right? However, it might be handy to know this one. It saves you a little bit of time. So I'll plug in values now, and I'm going to take just over, let's see, I'm going to go from the bottom to the top. So I'm going to call this the initial at the bottom, and final is at the top. And I'll have, so final at the top, oh, that's 0. It has to turn around, so I know the velocity is 0 at the top. Minus, let's see, I'll take upward as being positive, and so this is 20 meters per second squared divided by 2, so the final is 0. Well, let's see, what do I want to call the initial? Let's call this x equals 0 down here, and so the final is going to be 40 meters, and the initial was 0, and when I do all this out, so I get 400 divided by 40, is that right? Yeah, 400 divided by 40 is 10, but I still have this minus sign out here, and then divided by 2 is 5, so minus 5 meters per second per second. As a side note, I should mention this planet is not Earth, because this would be 10, or 9.8 to be more precise, if this were Earth. So wherever she is, it is not Earth.